Welcome back. Joining us today is Miss Lauren Peterson, and I'm Elizabeth, and she's got a great story she's talking about today. It's pretty interesting. Lauren, what did you call your piece?
I called it House of P.
House of P. So, you know, my mind just kind of ran a few different ways when I first saw this title. I'm imagining a lot of things. Maybe you could kind of simplify my imagination.
What are you imagining?
It's a whole another show.
Oh,
Yeah.
okay.
So,
Chirp, chirp, chirp. Okay, so basically, the EPA says that construction industry accounts for 40% of the world's CO2 emissions. And they're also saying that 40% of the U.S. landfill waste is due to concrete and construction stuff.
Yeah.
So clearly, you know, homes are being built every day. Homes get destroyed every day. People have fires, arson, stuff like that. We've got to be more environmentally friendly about the way we build our homes. And we've got to cut down on this waste as much as possible.
Totally agree.
So Peter Trimble, who was a student at Edinburgh, he designed this material he calls dupe. And dupe is a mixture of bacteria, calcium chloride, and urea.
Stop right there. How did he discover that this, like, hey, like the first day of research, and he decided this is the material that's perfect? How does this happen?
I imagine him and his roommates had some kind of long pee contest where they tried to see how much pee they could collect.
After like a really long keg stand?
Yeah, and but he says that didn't happen, so whatever. There's really not a lot of detail. He's really, really mysterious about like where this magical urea ingredient comes from. But in case you didn't know, urea is what makes pee smell like pee. It stinks. But apparently,
does that mean my home is going to smell if I have a pee house?
No, apparently the urea, you know, is kind of extracted and processed with the bacteria and stuff, and it's nutrient rich. And it creates the dupe, which is basically biodegradable concrete, and it has 70% compression strength of actual concrete, which means that it's pretty viable for home building and development. I mean, there's still a lot of testing being done, but it's actually being used in places like Morocco and with Aboriginal tribes.
Wow.
To see how it can be applied. Like, it's actually being used now.
So do they have like a frat house set up outside of every mixing plant for the materials?
I'm not really sure. I do know that he said he's a design engineer, so he did a lot of research with actual environmental engineers, consulting. He did a lot of research and stuff. He did a lot of research into this PP brick that he created.
Fascinating.
And the good thing about it is, as much as, you know, the angle here is PP, because, you know, PP is a fun word to say.
Y'all can say it at home too. Just say it one time.
It's energy efficient because producing it takes up less energy than producing concrete. It's biodegradable. It's cost effective. It is, and you really don't even need pee. I don't know how to get to the urea. I'm sorry, I don't have that information. I wasn't that pressed. But you don't necessarily need to collect buckets and buckets of pee and mix it with like sand, rocks, and bacteria to create bricks. Don't try it at home, please. We don't want pee smelling houses and stuff like that. But it's our waste
You're
could
going to
be
have
the way
to
of the
find a
future.
different summer job. So that's what that means, basically.
Yeah.
Well, that is some riveting stuff you brought to the table today, Miss Lauren. Thank you for
Imagine the
that.
pee banks that will pop up everywhere. You get broke.
That's
Instead of
behind every
donating
bar.
sperm, you donate pee.
Yeah, there you go. All right, well, thank you so much. And thank you for joining us today. And we'll see you next time here on Our Simple Earth.